In 2022, Google's parent company, Alphabet, spent approximately $31 billion on capital expenditure. In 2026, it expects to spend between $195 billion and $205 billion. That is more than 6 times as much in just 4 years. This money is not being spent on futuristic offices, free employee lunches, or another messaging app that Google might shut down next year. The vast majority is going into the infrastructure required to build and operate artificial intelligence. Data centers, servers, networking equipment, GPU, Google's custom AI chips, and enough electricity to keep the entire system operating. So why is one of the most profitable companies in history making a bet this large? Because Google believes the next era of the internet will run on AI, and it cannot afford to lose control of it. Before we continue, there is an important distinction. Google is not handing $200 billion directly to its Gemini research team. This figure is capital expenditure, commonly called CapEx. CapEx is money used to purchase or construct long-term assets. In Google's case, that primarily means the physical and technical foundation required to operate modern AI systems. During the second quarter of 2026, Alphabet spent approximately $44.9 billion on CapEx. Around 60% of its technical infrastructure investment went into servers. The remaining 40% went into data centers and networking equipment. So when people say Google is spending $200 billion on AI, what they really mean is that Google is building an industrial-scale computing network, capable of powering AI across Search, Cloud, Gemini, YouTube, Workspace, and thousands of enterprise customers. This is not merely a software project, it is one of the largest infrastructure expansions in corporate history. The first reason for this enormous investment is simple. Google does not currently have enough computing capacity to satisfy demand. And that demand is coming from both inside and outside the company. Internally, Google needs computing power to train increasingly capable Gemini models. It needs more capacity to operate AI features inside Search. It needs infrastructure for Gemini, YouTube, Gmail, Docs, Android, and its growing collection of AI agents. Externally, Google Cloud customers are demanding access to GPUs, TPU, Gemini models, enterprise agents, and AI-powered security services. Google says it has remained in a supply-constrained environment even after substantially increasing capacity over the previous 3 years. In other words, it is building more infrastructure, but customer and internal demand are growing even faster. The company has even started using expensive third-party computing capacity as a temporary bridge while it builds more of its own. That may hurt margins in the short term, but Google believes losing customers because it cannot provide enough computing power would be far more costly. Google's AI demand is no longer theoretical. It is already appearing across the company's financial and usage numbers. During the second quarter of 2026, Google Cloud revenue increased 82% year-over-year, reaching approximately $24.8 billion. Its contracted cloud backlog reached $514 billion. That backlog represents business customers who have committed to purchasing Google Cloud services in the future. Nearly 90% of Fortune 100 companies now use Gemini Enterprise. More than 9 million developers build with Google's models every month. Google's first-party model APIs process approximately 22 billion tokens every minute. And the consumer Gemini application has reached approximately 950 million monthly active users. These numbers help explain the spending. Google is not building infrastructure and hoping customers eventually arrive. Customers are already arriving. The problem is that Google needs enough chips, servers, networking, and energy to serve them. Google's second reason is strategic. Unlike many AI companies, Google controls almost every layer required to create and distribute artificial intelligence. At the bottom are chips. Google has spent more than a decade developing custom AI processors called tensor processing units, or TPU. Its 8th-generation TPU architecture includes 2 specialized chips. The TPU-8T is designed primarily for training massive models. The TPU-8I is optimized for inference, the process of using a trained model to answer questions, generate content, and operate AI agents. Above the chips are Google's networking systems, data centers, and cloud platform. Above that are models such as Gemini and Gemma. And above the models are products with billions of existing users: Search, YouTube, Android, Chrome, Gmail, Docs, Maps, and Google Cloud. This full-stack structure gives Google an enormous potential advantage. It can design the chips for its models, design the models for its infrastructure, and distribute those models through products people already use every day. Google does not need to depend entirely on another company for its chips, cloud platform, operating system, browser, or distribution. The $200 billion investment is designed to strengthen every part of that stack. The third reason may be the most important. For more than 2 decades, Google Search has been one of the greatest business models ever created. The user searches for something, Google understands the user's intent, and businesses pay to appear at exactly the right moment. But generative AI is changing the way people discover information. Instead of searching through 10 blue links, users can ask an AI assistant a complete question and receive a direct answer. That creates a potential threat. What happens if users begin their internet journeys inside ChatGPT, Claude, Perplexity, or another AI platform instead of Google? Google's answer is not to resist this change. It is to place AI directly inside search. AI overviews, AI mode, conversational search, and agentic features are designed to make Google itself the AI assistant people use to navigate the internet. This transformation requires dramatically more computing power than traditional search. Generating an AI response is more complex and expensive than retrieving a list of links. But Google appears willing to accept that cost because protecting search protects the engine behind much of its advertising business. To be clear, Alphabet says AI is increasing search usage, and that search and other advertising revenue grew 17% during the quarter. But strategically, Google is still racing to make sure the AI interface replacing traditional search is built by Google, not by a competitor. There's also a much bigger opportunity than Gemini subscriptions or AI-powered search. Google wants other companies to build their AI businesses on Google infrastructure. Think of the AI economy as a new industrial system. Models need chips, chips need servers, servers need data centers need high-speed networks, cooling, and massive amounts of electricity. Businesses then need models, databases, security, developer tools, and platforms for operating AI agents. Google wants to sell access to that entire system through Google Cloud. It can provide NVIDIA GPUs, it can provide Google TPUs, it can provide Gemini models and models from other companies. It can provide data storage, cybersecurity, analytics, and enterprise agent platforms. It has even begun selling complete TPU systems that customers can install inside their own data centers. The opportunity is no longer just selling cloud storage or rented servers. Google is trying to become one of the foundational infrastructure providers for the entire AI economy. If AI becomes embedded into every major company, Google wants to earn money every time those systems are trained, operated, secured, or scaled. A $200 billion investment only makes sense if it creates multiple streams of revenue. Google has several. First, AI can protect and potentially expand its search advertising business. Second, Gemini can generate subscription revenue from consumers and businesses. Third, developers pay to access Gemini models through APIs. Fourth, companies pay Google Cloud for infrastructure, storage, security, and AI services. Fifth, Google Workspace customers can pay for AI capabilities across Gmail, Docs, Sheets, and Meet. Sixth, Google can sell or lease access to its custom TPU technology. And finally, AI can make Google itself more efficient. Google says AI now generates a significant portion of its new internal code, which is then reviewed and approved by engineers. It is also using agents for cybersecurity, software migrations, and operational tasks. The investment therefore has 2 possible returns. Google can sell AI to customers, and it can use AI to reduce the cost and increase the speed of running Google. But this strategy carries enormous risks. The first risk is financial. Alphabet reported negative free cash flow of approximately $5.9 billion during the second quarter, largely because of its capital investment. New infrastructure will also create years of depreciation, maintenance, staffing, and energy expenses. The second risk is technological. Google could spend billions building infrastructure for today's AI architecture, only for a more efficient technology to reduce the amount of computing power models require. The third risk is competition. Microsoft, Amazon, Meta, OpenAI, and other companies are also investing aggressively. Google may spend more without gaining a decisive advantage. The fourth risk is monetization. AI usage may continue growing rapidly, but that does not automatically mean customers will pay enough to justify the infrastructure behind it. And the final risk is execution. Constructing data centers, securing energy, acquiring chips, and coordinating networks across multiple locations is extraordinarily difficult. This is not a software update that can be released next week. It is a multi-year construction and supply chain challenge. Google is betting that AI demand will remain strong enough for long enough to produce attractive returns on this infrastructure. So why is Google spending approximately $200 billion on AI? Because AI is no longer just another product category. It could change how people search for information, how companies purchase software, how developers build applications, how advertisements are delivered, and how digital work gets done. Google is spending this money to achieve four things: to create enough computing capacity to meet demand, to control the full AI stack, to protect search from new AI competitors, and to make Google Cloud a foundational platform for the AI economy. The $200 billion figure sounds extreme. But from Google's perspective, the greater risk may be spending too little and allowing another company to control the interface through which people access information. Google is not simply trying to win the chatbot race. It is attempting to build the infrastructure beneath the next version of the internet. The only question is whether that infrastructure becomes Google's next great business empire or the most expensive technology gamble in history. What do you think? Is Google investing at exactly the right moment, or is the AI industry building far more computing capacity than it will ever need? Leave your prediction in the comments and subscribe for more business and technology stories explained without the hype.